Okay, so this is our fourth type of transformation that we're learning. Can y'all name me the first three? Translation, reflection, rotation, and now this is our fourth, dilations. And just like we just talked about, a dilation, like getting your eyes dilated, talking about your pupils in your eye, they can either get larger or smaller. So dilations can go both ways. They can either be an enlargement or a reduction. But how do I know how much larger or smaller an object is getting? It's what we call scale factors. Scale factors tell us by what proportion. It's got to be the same thing happening to all the ordered pairs. All right, we have to have the same shape, but it will be now a different size. Okay, so what's an example of a dilation? Well, a scale drawing could be. Can anybody raise your hand and give me an example, a real life example of a scale drawing? Real life, Maddie? Yep, a house blueprint, right? So a house blueprint in real life, obviously the contractors build it huge, but they have to go off of something, and blueprints are drawn to scale. Usually it's called a 1/4 inch scale. So for every 1/4 inch that measures on that blueprint, it represents 1 foot in real life. Okay, so it's not just a picture of the house, it actually is drawn to scale. All right, and that's important. Okay, so a scale drawing is a blueprint. Anybody else think of one that might be kind of common, especially maybe for your parents and grandparents? Something that people used to keep in their cars? Addie? Yes. Has anybody, I know. Has anybody ever seen a map of Florida? Please raise your hand. You've seen a map of Florida, right? Okay. So back in the day, we used to use, no, not we. Okay. When I was a teenager, it was MapQuest. So we would put it in online, but our phones didn't have GPS. So we would put it in online, and we would print out the directions, but if we had to make a different turn, then the directions were no good. So that was a little... But even before MapQuest, that's how people got around. They'd pull out the map, and it would tell them which roads to take on their road trip. Yeah, now Siri just tells us where to go.
Hey Siri, find the nearest McDonald's.
Okay, so in example 1, it's just real easy, okay? We're identifying dilations between the two figures. Are they changing size? Yes or no? Okay, so on the first one, my triangles from red to blue, are they dilating? Nope. What is it?
Translation.
So we say no, not a dilation because it's a translation. Okay. What about the second set?
No.
Yep. Not a dilation, it's a reflection. Okay, what about my third set? Yes. From red to blue, it is a reduction. It's getting smaller. Well, it's on the screen. It's on the screen. I know it's black and white on your notes. Well, so on the last one, from blue to red, what do you think? Enlargement. Stop it. Okay, yes, it's an enlargement. You guys are ridiculous. Okay. Okay, so now gets down to really the heart of what we're doing today, and that's dilating a figure. Okay, so the middle blank is for us to show our work, but you're not going to have to do that step on a quiz or test. It's there if you want to, really just see. But the math that we're going to be doing is very basic math. So we assume that you could do that mental math. So the scale factor tells me what to multiply my ordered pairs by. All right, but before we do that, I want you to go ahead and take these 3 original points and put them on the graph. Go ahead and do A, B, and C and plot them on the graph. All right, does yours look like this?
Yes.
All right, it's little and cute. Okay, so now because my scale factor is 3, okay, so here's my rule of thumb. If my scale factor is greater than 1, that means it's an enlargement, okay? So I want you to circle enlargement. Based on the scale factor, I know that it's an enlargement because it's greater than 1. The scale factor of 3 means that I am going to triple the size of this triangle. And how I do that is I take my x and my y value and I multiply everything by 3. Okay? So 1 times 3, and that's what we're going to write in this middle blank. Okay? Now again, we will assume that you can do this mental math. For now, let's write out the steps so we can really see what we're doing. But to multiply x and y by 3, I'm making that ordered pair larger by a scale factor of 3. Now my new ordered pair is 3, 9. And I do the same thing for all of them. So what's going to be my new ordered pair for B? 6, 9. Okay, 6, 9. And then for C, what's going to be my new ordered pair? 6, 3. Now let's take these ordered pairs. Obviously 9 goes off the chart, so we're just going to draw it above the graph. Over 3 up 9, over 6 up 9, and over 6 up 3. And then we can draw the dotted lines connecting the 3 points. Okay, and we have now done an enlargement. It's dilation. It's an enlargement from the original to the image. Okay, don't forget your little prime markers after the A, B, and C. Okay, all right, so on the next example, we're just doing the same thing again, except now we have a different scale factor. Now we have a scale factor of 0.5 with original points, W, X, Y, and Z that form a rectangle. Again, this one's going to go off the chart a little bit, and that's okay. All right, so the first thing I want you to do is plot your 4 original ordered pairs on the graph. For the 8, just go a little bit above the graph, like 1 unit above the top of that graph. All right, so let's go ahead and plot our original rectangle. Okay, does yours look like?
Yes. Yes.
Just about like that. Okay, so now we know based on the last example, if the scale factor is greater than 1, it's an enlargement. And if it's less than 1, what do you think it is? It's a reduction, okay? So circle reduction. And when it's less than 1, that means that I'm actually dividing by the scale factor, okay? So it's division, it's making it smaller. So 0.5 is pretty simple, that's half, okay? So all I'm doing is I'm taking half of the original ordered pairs. All right, if it was 1/3, I would divide by 3. If it was 1/4, I would divide by 4. All right, in this case, it's 1/2. So what's half of -4? -2. Okay, and what's half of -6? -3. And again, that middle blank is for us showing our work, but again, that's kind of an optional part, but basically what we're doing is we're dividing each value in the ordered pair by 2. All right, let's go ahead and finish. If you could get X, Y, and Z, and then plot those ordered pairs. All right, so my new ordered pairs, -2, 4, 2, 4, and 2, -3. So now I'm going to plot those on my graph. And if you guessed that it would be inside the original, you were right. Okay, so my image is half the size. How did I know half? Because that's my scale factor. W prime, X prime, Y prime, and Z prime. and there's my image. All right, any questions on that? Okay, so we did an enlargement, we did a reduction. Now on the next, are y'all ready to move on? On the next example, we're going to take a set of ordered pairs. This is a trapezoid now. Okay, we're going to take a set of ordered pairs through 2 transformations. This means that I do one transformation, I come up with a new set of ordered pairs, then I take that set and I transform it again. So let's look at the instructions. It says to dilate the trapezoid using a scale factor of 2, then translate it 6 units right and 2 units up. Then it wants to know what are the coordinates for the final image. Okay, so you have an idea what we're going to do? Okay, the first thing you're going to do, if it's a scale factor of 2, what are you going to do to all your order pairs? Multiply by 2. Okay, so go ahead and do that. Okay, so for my dilation, did you get -4, -2? Did y'all get that? Did you get -2, 2?
Yes.
Did you get 0, 2?
Yes.
And did you get 0, -2?
Yes.
Okay, so now tell me this. To translate it 6 units right means what operation to what value? Can someone raise your hand? Alexa.
Add 6 to the x.
Perfect. Add 6 to x, and then to go 2 units up, what do I do to do that, Jack?
Add 2 to y.
Add 2 to y. Plus 6 and plus 2. So that plus 6 and plus 2 just tells me this is what I'm doing to all my x and y values. It's not necessarily like you don't have to write that. Okay, I'm just kind of writing it there as a reminder. To add 6 now to -4. What's -4 plus 6?
2.
2. What is -2 plus 2?
0.
0. Okay, go ahead and finish the rest of those ordered pairs. Got them? Got them, got them. Lydia, what'd you get for B?
4,
4 and 4? Yep. All right, Aiden, Austin, what'd you get for C? He said 6, 4. Do you agree? Very good. And Janice, what'd you get for D? Yep, 6, 0. All right, very good. So we're going to stop here. We have example 5 still to cover tomorrow, and I'm going to throw in one more example tomorrow as well. But we've done enough that you could actually do most of the homework. So we'll spend the last few minutes of class getting started on homework.